In this video, we will learn how to estimate fabric capacity using Azure Calculator. First, we will understand the key components involved, and then we will walk through how to use Azure Calculator step by step to arrive at an estimate. If you like to dive deeper, all my detailed notes are available in the GitHub link provided in the description. Now let us start with the most important component in fabric estimation, that is fabric compute capacity. Capacity in Microsoft Fabric uses something called SKU, or the stock keeping unit. Think of an SKU as a package that provides a specific amount of compute resource for your organization. An organization can have multiple capacity depending on their requirements. Fabric compute capacity, or the FSKU, act as a shared compute pool, which means all the workload in the fabric like the Power BI, Spark, data warehouse, data engineering and other services consume the resource from this common compute pool. Looking at the pricing aspect, FSKU are billed on a hourly basis. This means the charges apply as long as the capacity is provisioned, regardless of whether you are actively using it or not. So one way to basically avoid this is, after the usage, if there are no spike in the usage, you can basically pause the capacity, so that you will never be billed for the ideal hours. Now let us understand capacity units, or CU. Each fabric SKU defines a certain amount of capacity units available per second. For example, F2 provides 2 capacity units per second. F256 provides 256 capacity units per second. With F256, you get an access of around 22 million capacity units available for a day to consume. So now let's talk about scaling. Fabric follows a fixed capacity model. For example, if you provision an F2 SKU, that means your allocated capacity. Fabric does not automatically switch from F2 to F64 and then switch back after processing completes. So this there is no automatic way to basically scale up and scale down in Fabric. So you can again scale up and scale down through a manually using Azure Portal, or a semi-automated way using Azure Logic Apps or Azure Runbooks. Now the question is, what happens if my workload temporarily needs more compute than my allocated SKU provides? That is where bursting comes into the picture. Bursting allows temporary usage beyond your provisioned capacity. Fabric also provides another mechanism called smoothing. Instead of consuming all the capacity unit instantly, Fabric distributes the usage over time. Let us understand bursting and smoothing with an example on a Spark compute. Let's say one Spark, one CU means one capacity roughly maps to 2 Spark core. Let's assume you have an F64 SKU, which means you have 128 Spark virtual cores as a part of the SKU. And a burst multiplier of 3x can then be applied, which means your maximum available virtual cores that are available for your F64 is 384 Spark virtual core. This means that an F64 capacity can temporarily provide up to approximately 384 Spark virtual core for highly compute intensive workload. Now a question happens: what happens if the workload needs more than 384 Spark virtual core? Fabric does not create unlimited resource automatically. Instead, one of the following thing can happen: either the job may enter in a queue or wait for resource to become available, or if the capacity is heavily utilized, new job may be delayed or temporarily rejected. Another option is to scale to a larger SKU, such as moving from F64 to 128 or 256, which provides higher compute. So another question here is how long a Spark job continue using 384 cores. There is no fixed duration. Spark can continue use those resources as long as sufficient capacity is available and the overall capacity budget has not been exhausted. Let me explain fabric compute capacity with a real world example. Imagine a large food court inside a shopping mall. The kitchen infrastructure like the cooking space, staff, electricity, the equipments represent the overall fabric capacity. Now imagine different food counters such as pizza, burger, desserts, and beverages. These can represent different fabric workloads like Power BI, Spark, data warehousing. Even though the customer places an order at different counter, all of them depend on the same kitchen infrastructure behind the scene. So a smaller kitchen can process only limited number of order, while a larger kitchen can process many more requests at the same time. So this kitchen size is similar to SKU in Fabric. So say for example, for F2 SKU can be a small kitchen, and F64 or F256 can be treated as a larger kitchen with more resource. Now imagine it is a peak time and suddenly customer demand increases significantly. The kitchen owner decides to temporarily bring in extra cook to handle the surge in order. So here bringing additional staff temporarily to manage the increased workload. This is similar to bursting in Fabric. In bursting, Fabric temporarily provides additional compute when demand increases without permanently increasing the provisioned capacity. Now to understand smoothing, let us consider a scenario. There are suddenly 500 customers arrives at the food court and they receive the entire kitchen gets 500 orders immediately. So eventually the kitchen becomes overloaded and operation slows down. Instead, the kitchen intelligently organizes the work. So the urgent customer orders are prepared immediately. Less urgent work such as ingredient preparation or bulk order can be scheduled over the time. So Microsoft works in a similar way. Rather than consuming all the capacity immediately, Fabric intelligently distribute the workload over the time. This is smoothing. So just to summarize, bursting is basically temporarily adding extra cooks during the peak demand. Smoothing is intelligently distributing work over the time. Now let us understand another important component in Fabric estimation, Spark Autoscaling, also known as Serverless Offloading. When this feature is enabled, Spark jobs are moved away from the reserved Fabric capacity and run on a dedicated serverless compute resource. This means Spark job does not consume capacity units from the fixed Fabric capacity pool. Now you might ask, why was this introduced? The reason is simple. The Fabric follows a fixed capacity model, and Spark workloads typically are heavy compute intensive loads. So a large Spark workload can consume significant resource and can affect other workload running on the same capacity. To solve this problem, Fabric provide Spark auto scaling with serverless offloading. The benefits of this feature is like true elastic scaling, which where the compute resource can be scaled up or scaled down based on the workload demand. Better workload isolation, because Spark workload no longer compete directly with other services like Power BI or a interactive warehouse query. And the third thing is protection for interactive workloads such as Power BI reports or data warehouse queries. Now that we understand Fabric capacity, compute capacity, and Spark autoscaling, let's look at some of the other important components that contribute to Fabric cost estimation. The next component is OneLake storage. OneLake uses a zone redundant storage or ZRS wherever available. If ZRS is not available, it falls back to locally redundant storage called as LRS. One important thing to remember is that storage cost and caching cost are charged separately. The default storage configuration protects against a hardware failure, but it does not protect against a regional failure. This is where business continuity and disaster recovery, also called as OneLake BCDR, comes into the picture. BCDR enables a cross-region disaster recovery. However, enabling BCDR has some impact on the storage usage. The storage usage typically increase. The capacity consumption also increase. Say for example, a normal write a BCDR write is 2x the normal write, which means say for example, a normal write takes around 1626 CU units. A BCDR write takes around 3056 CU. Now coming to OneLake, there is another aspect is OneLake cache. OneLake caching is mainly useful when accessing external data stores such as Amazon S3, Google Cloud Storage, or some other on-premise system. The purpose is simple, basically to reduce the latency, reduce the repeated external read, and reduce the egress cost. But one thing that so as a part of caching, Fabric basically store a local copy inside OneLake, and the duration for this cache is from 1 to 28 days. Next is mirroring. Mirroring automatically replicates the data into Fabric storage. An important thing here is that the compute for mirroring is already included, so there is no separate compute cost. Finally, let's discuss the data transfer cost. Charges are applied when data moves across the region. Data is ingested across the cloud provider. One common risk to watch here for is the region mismatch. If your Fabric capacity is deployed in one region while your data exists in another region, you may incur additional egress charges. Now let's look at another important component in Fabric estimation, Power BI licensing. Unlike tools such as Tableau, Fabric pricing is not purely based on the number of users. Fabric allows a combination of capacity-based and user-based licensing. Let's understand the common licensing option or in Power BI. The first is premium per capacity, also called as P capacity. P capacity is a higher tier capacity model that provides all the capability available in Fabric and is built based on the capacity rather than the individual user. This model is generally suitable for a large organization with many users consuming reports and analytical content. So say for example, for an organization with small number of users, using a large P capacity may not be a cost effective option. In such scenario, use an Fabric SKU combined with any of the user licensing, maybe that would be a better option. Now coming to the licensing at the individual user, we have premium per user. The premium per user or PPU is useful when you need advanced capabilities of Power BI, like the high refresh frequencies, SMLA endpoint, advanced semantic model capabilities. So next is Pro licensing. Pro licensing is a standard licensing model used for content creation, sharing, and collaboration. For organization do not need premium feature or very high frequency refresh are not needed, then Pro license are often sufficient. So in the project which I work, we use an F256 with the Pro licensing. That is a pattern that we follow in our organization. Again, PPU licensing are needed only when advanced capabilities are required. Now let's see how we can estimate Microsoft Fabric cost using an Azure Pricing Calculator. Go to Azure Pricing Calculator, select an estimate template. For this example, we will select Design an Enterprise BI Solution, which is under Data and Analytics. Once the template opens, you may notice that multiple services are already added. For example, Azure SQL database may appear in the estimate. Now, the important thing to remember here is that Azure SQL database is not a core requirement for Microsoft Fabric. However, some organization may use Azure SQL for their metadata, in their metadata driven framework for storing the configuration, logging, or any application specific requirements. If your architecture needs that, you can retain it and modify the configuration accordingly. For our example, we are not using it, so we can remove it. Now let's configure Fabric capacity. In this example, we are using two separate capacities, one capacity for data engineering and one for presentation. Separating the capacity helps isolate workload, so any data engineering activity will consume one set of capacity, and reporting related can use a different set of capacity. So let's create a F32 SKU for data engineering, and you can choose between pay as you go or reserved pricing. In reserved pricing, based on the duration, there is a reduction in the price. The next step is storage estimation. I am using I'm giving 5 TB for OneLake storage. So in case of cache, there will be another amount that will. Now coming to presentation layer, in the template you may notice that additional storage is shown as 0. That does not necessarily mean the presentation layer never requires storage. The storage requirement depends on how a Power BI semantic model and the reports are designed. For users creating report, we typically need to consider Power BI licensing such as Power BI Pro or PPU license. These licenses are required for report creation and premium feature access depending on the use case. Now, an important thing to understand here is the Power BI native storage and OneLake storage are two different concepts. Power BI maintains its own semantic model storage, while OneLake storage is it's basically for the Fabric data assets. Storage requirement can increase depend on the number of model data, volume, refresh frequency. So the import versus the direct lake design choice. So So during the estimation, so do not assume zero storage for the presentation layer by default. Instead, validate the reporting architecture and the licensing model before finalizing the estimate. Finally, notice the pricing section at the bottom. If your organization already uses Azure service and has an existing agreement such as enterprise agreement or Microsoft customer agreement, the calculator can reflect those negotiated prices after signing. So two organizations using exactly the same architecture may still see different final pricing based on their agreement and the discounts. This estimate gives us a starting point, and from here we can continue refining the storage, capacity size, licensing and additional services based on the business requirement.